Now, for this last screenshot, we'll loosen up a little bit. So what if I don't know how to factor? I forgot what GCF means. I don't know how to do the X method. So how can I graph a quadratic function? Here's another method that you can use in order to graph any quadratic function, whether it's a binomial or trinomial or monomial as well. It works for all, but you have to be wise as to what points you're going to use later on, and I'll explain to you why. Okay, so one thing that we can't get away with is the vertex. You have to know how to find the vertex. So you have to memorize this formula no matter what. X is equal to negative b over 2a. So let's do that here. The axis of symmetry, x is equal to opposite of b, but your b here is 12. So b is 12 and a is 2. So let's write that down in the formula. Opposite of b will become negative 12 all over 2 times the a value, which is 2. So negative 12 over 4, that will give you negative 3. Now, once you find the x coordinate of the vertex, plug it in. So f of negative 3 is equal to 2 times negative 3 squared plus 12 times negative 3 plus 4. And this will give us, so negative 3 times negative 3, or negative 3 squared, is 9 times 2 is 18, minus this will become 36 plus 4. So this gives us 18 minus 36 is negative 18 plus 4, and the final answer for that one will be negative 14. So that means your vertex will be at negative 3 comma negative 14. Okay, so on the right hand side, you will see the graph here. I have the axis of symmetry, which is negative 3, and then I have the negative 14 all the way at the bottom. So our vertex can be found here. That's our vertex. Okay, so now we have a problem. If you look at this quadratic trinomial, they have a GCF, which is 2. So if I take out 2, it will become f of x is equal to 2 parentheses x squared plus 6x, that's plus 6x plus 2. However, this cannot be factored anymore. So the only factors of 2 are 2 and 1. And there's no way if we add or subtract them, you're going to get a 6. So that means this is not factorable. So we can't use the FRAB method. So what are we going to do now? Well, now that we know the vertex, which is negative 3 and negative 14, all we need to do is choose a convenient point, either to the left or to the right of the axis of symmetry. Now, convenient point meaning don't think of a big number. Don't think of something that will make you compute something like this long again, right? So usually a convenient point that we use is the y-intercept. So why do we use the y-intercept? We use the y-intercept because the y-intercept has an x value of 0, right? So that means we're just going to substitute 0 for x, which is very simple to do in this function. Either you use the original function or you factor out, or the factored out version. So let's say you want to use the original function. Let me erase this one because it's not factorable anyway. So if we use the original function, let's plot f of 0. So when x is 0, we're trying to get the y-intercept. So this will become 2 times 0, which will become 0. And then 12 times 0 will also become 0. So what's left? Well, you have the value of c, which is 4. That's your y-intercept. So that means one point on the graph is actually 0, 4. So where is that point? This is 0, and then you go 1, 2, 3, 4. That's your convenient point, which is 0, 4. Okay, and then it says here, use symmetry. Use symmetry to find its partner. So we know that this point is actually symmetric with respect to the red line. So how many spaces is that away from the red line? That's 1, 2, 3. So you go 1, 2, 3 spaces also on the left hand side, and you get the other point. So if this is 0, positive 4, what would this point be? This point will be this is -3, -4, -5, -6. So this will become -6, comma 4. So that's going to be the point of our parabola on the left hand side of the x-axis. Okay, well, let me try again to connect those three. So connect that point to your vertex down there and then curve upward and hit your other point right there. Okay, so just make sure that your curve is better than the one that I drew, and that should give you the graph of this function. So even though it wasn't factorable, we used the vertex and the axis formula, which is -b/2a, and then I suggested finding the y-intercept and use symmetry to find its partner on the other side. All right. So I can hear you say already, well, that's easy. I like this method. So the next question is, can I do this for all quadratic functions? Well, the vertex formula works for all. So steps 1 and 2 can be used for anything, any quadratic function, I mean. So there are just instances when you will be required to indicate the x-intercepts accurately. So if that's the case, I suggest using the FRAB method. But even for the quadratic functions that we looked at in the previous lessons, like the ax2+c or the ax², now this method can also be used. So this is like the jack of all trades, method. So if you like this, yeah, make sure you have a lot of practice on this one. You just have to kind of combine it with other concepts and formulas that we learned in doing the practice later on, because I will be asking specifically for what are the roots, what are the x-intercepts, what's the y-intercept, if any, and so on. Yeah, so you just mix and match from all the methods that I presented to you in this lesson.